Alright, hi everyone. Today we're going to do exercise 1.1 in the first chapter, number systems. This is class 9 NCERT maths. So we have question 1 which says, is 0 a rational number? Further, can you write it in the form p by q where p and q are integers and q is not equal to 0? And the answer to this is absolutely yes. 0 is a rational number. We can write 0 in the form of p by q in many ways. You divide 0 by any integer, any non-zero integer rather, and this will always be equal to 0. Hence, there are multiple ways to represent the number 0 in the form of p by q, such as the three ways I have mentioned over here. Here q is not equal to 0, p and q are integers, where p is the numerator and q is the denominator. So we can safely say that yes, 0 is a rational number. Moving to question number 2, it says find 6 rational numbers between 3 and 4. Now I'm going to draw the number line over here. Let's say this is 3 out here. This is the number of 4. Now we know that there are infinite number of rational numbers between these two numbers. And the question is asking us to find any 6 of them. So let's say the midpoint over here. Midpoint of 3 and 4 would be 3.5. Right? Now that's a rational number. How do we know it's a rational number? As long as it can be put in the form p by q, and we can suggest that the denominator q is not equal to 0, we know that this is a rational number. So let's try and put the number 3.5 in this way. I can write 3.5 as 35 by 10 and then simplify it, divide 5 in the numerator as well as the denominator, and I get 7 by 2, which is nothing but 3.5 in its fractional form. This is in the form p by q, and q is not equal to 0, so this is our first number out here. Now I need to find another number between 3 and 4, which is a rational number. Just like I took out the midpoint between 3 and 4, I can take out the midpoint between 3 and 3.5, right? Another way to take out the midpoint is adding both the numbers and dividing it by 2. So I have 3 plus 3.5 divided by 2. This will be the midpoint right here. So this becomes 6.5 by 2. In other words, 65 by 20. And then when I divide both the numerator and denominator by 5, I get 13 by 4. This is in the form p by q, where q is not equal to 0. So this gives us our second rational number between the numbers 3 and 4. Just like we took out the midpoint between 3 and 3.5, we can also take out the midpoint between 3.5 and 4, which will roughly lie somewhere here on the number line, and this will also be between 3 and 4. So if we do that, and just gonna take some space out here. So to take out the midpoint between 3.5 and 4, I'm going to add these two numbers and divided by 2. So this becomes 7.5 by 2 or 75 by 20 or 15 by 4. Fifteen by 4 also gives us another rational number between the numbers 3 and 4. The midpoint way is one way to do this. There are n number of ways to get a number between 3 and 4, right? For example, let me take a point close to here, which could be something like maybe 3.9, right? 3.9 is also a number between 3 and 4. And it is definitely a rational number. And we can check this out by representing this in the form of P by Q. (39 by 10) remains in its simplest form since 39 and 10 do not have any common factors. So 3.9, or in other words 39 by 10, is also a rational number where we can see where P is 39, Q is 10, Q is not equal to 0. It's a rational number. So here we got 4 numbers between 3 and 4. Similarly, we can take another 2 numbers, let's say 3.1 or 31 by 10, also between 3 and 4, rational number. And let's say 3.2, which is 32 by 10, or in its simpler form 16 by 5. These 2 numbers are also between 3 and 4. And this gives us 6 rational numbers between 3 and 4. Moving on to the third question of this exercise. Slightly similar to the old one. Find 5 rational numbers between the numbers 3 by 5 and 4 by 5. So just like the old question, I am representing these numbers out here. Say this is 3 by 5 out here. This is 4 by 5 out here. And we need to find 5 rational numbers between this, right? Let's use the midpoint way of getting these 5 numbers. So like we did in the earlier question, to get the midpoint between 3 by 5 and 4 by 5, we add these numbers and divide it by 2. Now this gives us 5 into 2 in the denominator, 7 in the numerator. This gives us 7 by 10, which is the midpoint between 3 by 5 and 4 by 5. P by Q, where Q is not equal to 0, hence a rational number. For our second number, we can get the midpoint between 3 by 5 and 7 by 10, which will be somewhere around here. And in order to do that, we do the same thing. We add 3 by 5 and 7 by 10 divided by 2. This gives us the number 13 by 20, which is the midpoint of 3 by 5 and 7 by 10. And it is a rational number P in the form P by Q, where Q is not equal to 0. Let's also take the midpoint between 7 by 10 and 4 by 5 by doing the same thing again. I'll add these two numbers divided by 2. This gives us 3 by 4. Now we have 3 numbers between P and Q. We need 2 more. I'm just going to use this space out here. So let's take out the midpoint between 3 by 4 and 4 by 5. This will be our 4th number. Do the exact same thing. 3 by 4 plus 4 by 5 divided by 2 gives us the number 31 by 40. Another number between 3 by 5 and 4 by 5, where P and Q are integers and Q is not equal to 0. Similarly, let's take any other 2 points, let's say 13 by 20 and 7 by 10, and take out the midpoint for that. We're pretty used to this approach of taking the midpoint now. I anticipate you would have done this much quicker than I've been doing, but I'll still lay it out. This gives us 27 by 40. And that gives us our 5th number between 3 by 5 and 4 by 5. So just to recap, the numbers that we found out: 13 by 20, 27 by 40, 7 by 10, 3 by 4, 31 by 40. All these 5 numbers are in the form P by Q, where Q is not equal to 0 and P and Q are integers, defining that these are all rational numbers and they're all between 3 by 5 and 4 by 5. And that solves question number 3 of exercise 1.1. Now we move on to question number 4 in exercise 1.1, which has 3 parts. It's basically a true and false question. So we're going to talk through this and we're going to give reasons for whether it's true or false. So the first part says every natural number is a whole number. So as per our definitions, we do remember natural numbers are simple numbers that we are used to when we are counting. So that's 1, 2, 3, 4, 5, 6, and so on. And whole numbers are all the natural numbers with the addition of 0 before our first count 1. So by that definition, yes, we know that every natural number comes in the purview of the whole numbers. So our first statement is definitely true. The second statement says every integer is a whole number. If we try and recall what integers are, they are all the numbers that we use in our countings with the addition of the negative numbers as well. So it starts from minus infinity, counts down, let's say to minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, and so on till we reach infinity. These are what integers are. Whole numbers, although like we discussed in the earlier statement as well, are all the counting numbers that start from 0 onwards, go till infinity. So this part that I have blocked. This means that within integers there exist lots of numbers that don't fall under the whole number subset. These are basically our negative integers, and hence this statement is definitely false, since we can think of examples where this statement is not true. The third statement says every rational number is a whole number. Rational numbers, like we know, are numbers which can be represented in the form of p by q, where p and q are integers and q is not equal to 0. Let's take an example of such number. 3 by 2. 3 by 2 is not a whole number. In fact, in its decimal form, it's 1.5, which lies between the whole number 1 and the whole number 2. However, any number between 1 and 2 is not a whole number. Hence, we can say that 3 by 2 is definitely not a whole number, but it is a rational number. So, which makes the statement number 3 also false. And that ends our exercise 1.1 of the first chapter, Number Systems. Thanks for watching this, and please do watch the other videos for solutions on the other NCERT exercises. Thanks.